We're going to move down one level of concretion here, and we're going to start talking about the effects of profit rate equalization on relative prices. So now we begin the theory of relative prices. And the first thing to remind you of is that in the classical tradition, market prices reflect demand and supply. As we're talking about prices which don't necessarily mean demand is equal to supply, only that they respond to demand and supply. And the reason is that we don't want to assume equilibrium. Demand and supply are independent entities, and they can pull on prices in different ways. So the classical economists are always talking about the fact that market price is going to be something, whatever it is, dependent on concrete conditions. And then they're concerned with what happens to market prices in the long run. And by the long run, they do not mean some mythical state of equilibrium. They mean over a time process, so a longer time interval. And here they make a distinction between two types of market prices. Market prices of goods whose supply cannot be expanded. For instance, rare goods, old paintings, old wines, antiquities, and something in such scarce supply that it cannot be reproduced. And those, obviously, the price will depend on the demand because supply is not expandable. Is that point clear? It's not the elasticity of supply here. We're talking about not increasing the supply. If the elasticity is low, it just takes longer. For instance, a rare wine is by definition something which is rare and is not reproducible. A good vintage, that is not available in further quantity, the price just goes up because the quantity is fixed. That's different from the production of, let's say, trees, lumber, which takes a long time. But that's an expandable supply. It's just the condition of expansion is that it's longer. Whereas for a rare wine or an old master's painting, the supply is fixed. So that's the first thing that Ricardo says right in the beginning of the principles. I'm talking here about two types of prices. One whose price is determined by its demand because its quantity is not expandable. But he says that's a small subset of the world of prices. The big subset, the big set, is those goods whose supply can be expanded sooner or later. And those goods, their price is regulated by cost, not by demand. Demand and supply play a role in bringing the market price down to the natural price, or the price of production, but they are not central because both of them are changed by the process. Everybody, I've repeated this many times, is pretty clear now. If the market price is high for whatever reason, and this is an expandable good, supply meaning that your profit rate is high, capital flows in, increases supply, so supply is not independent of the market price here, or in this case, it's not independent of the deviation of the profit rate from the normal rate, and it brings the supply up and brings the price down until the market price comes down to a level that corresponds to a normal rate of profit on the regulating capital. Now, we went through a lot of that detail, and it's important to keep that detail in mind. So is that okay? So we're concerned here with cost-determined prices, as is typically in the classical tradition. Now, point number 2. Adam Smith developed an astonishing argument in which he shows that you can decompose the price of any commodity into its vertically integrated, what I call integrated, direct and indirect unit labor cost and direct and indirect profit. And that turns out to have a very powerful analytical implication. So that's the first thing I want to show you now. Consider that I can break the price of any commodity into unit labor cost, unit profits, and unit materials costs. That's a straightforward decomposition, and this is an identity because by definition, profits is the difference between costs and price. So this is purely an identity. It's always true, and it's true for every price, even a price where the profit is negative, where unit labor cost is the wage rate times the amount of labor. This is in L. One of the terrible things about modern fonts is it's hard to tell the difference between an L and a 1. But this is in labor per unit output, wage per unit labor, and so the product of the two is unit labor costs. So price as an identity is equal to unit labor costs plus unit profits plus unit materials. Now this is an identity, but it's a very powerful identity, as identities can sometimes be, because as soon as you look at this term, which is the materials cost and depreciation, I'm skipping over the difference between these two here, but this is input costs. Well, what is an input cost? It's just the price of a bundle of goods, of materials and the depreciated part of machinery and so on. So I can take this materials costs here and I can break it into the unit labor costs of the materials costs, the unit profits of the materials costs, and the unit materials costs of the materials costs. Right? And if I had this information, I could continue doing that. When I'm left over with this residual, it's going to be smaller than this because it's only a portion of this. This is going to be, let's say, 10. I break it into 3 and 5, and here I have a 2. This 2 will then be broken into unit labor costs of the materials costs of the materials costs, unit profits of the materials costs of the material costs, and the unit materials costs of the materials costs of the materials costs, and so on. Now, evidently, if I do it that way, I'm going to get a series in which the residual goes to 0. And that means I can group all the terms into unit labor costs directly, first stage back, second stage back, third stage back, and these stages are analytical stages, not temporal. And profit margins, or profits per unit output, plus profits per unit output on the inputs, plus profit per input, unit output on the inputs of the inputs, and so on. And evidently, each one of these terms will be smaller, so they'll be a convergent series. And therefore, I can always group the terms together. I can group the first set into a collective term, which is vertically integrated unit labor costs. That's using Passanetti's definition of vertical integration, or integrated unit labor costs, integrated over direct and indirect stages, and integrated materials costs. So I'm going to call the first one VULC, which is the sum of all the direct and indirect unit labor costs, and VM, which is the sum of direct and indirect profit. And by this simple device, I can write any price, market price, monopoly price, disequilibrium price, it doesn't matter, as the sum of vertically integrated unit labor costs and vertically integrated. If I factor out the vertically integrated unit labor costs, then I get 1 plus the ratio of vertically integrated profits per vertically integrated wages, because the output units cancel out. And so I have vertically integrated unit labor costs times 1 plus the vertically integrated profit wage ratio. And of course, vertically integrated unit labor costs is the vertically integrated wage times the vertically integrated labor time, which I'm calling V, times this distribution term. And the V is the equivalent of Marx's unit labor value. So what I've done, and this is, you can see, a natural way for the classical argument to proceed, is I've taken any price and broken it into the product of the wage rate, labor value, or integrated labor time, and a distribution term. Now, this actual process can be done through an input-output table, because that allows us to translate unit labor costs of unit labor costs and labor costs and so on. That's just a simple process using the I minus A inverse matrix. So this has a direct analog for calculation purposes. If we could trace the inputs, which we can do with an input-output table, this is a straightforward process of transformation of the components of direct price into vertically integrated components. On my homepage, I have several papers using this technique for transforming prices of production or Sraffian prices into this form. It's a very powerful form because it simplifies the understanding of the process tremendously.
Can you explain one more time where the unit material cost went to the A value? Is a progressive series or something goes down to zero?
Yeah, so let me write that out. Suppose that I had the price of something was equal to unit labor cost plus material plus profits per margin and unit materials cost. Let's say this is 100, this is 70, this is 20, and this is, let's make it 60, 20, and I'm trying to make the numbers big enough so that I can 30 and 20, okay? So this is the materials cost, which is 20 out of 100 in the price. But I can break this, which is just simply the price of some bundle of goods, into the unit labor costs of that bundle, and the profits of that bundle, and the materials costs of the materials costs of that bundle. It's just a bundle of goods. And you can see that that is going to have to add up to 20. So if this is 7 and this is 5 and this is 8, it doesn't really matter. You can see that this 8 is smaller than the original because it's a fraction of it. Each one of these is smaller than the original number. And so I keep adding numbers, and the A is going to, in the residual, converge to 0. Okay? And this is, by the way, a natural way. If you understand how businesses work, it's a pretty natural way to think about it. You can see why Adam Smith understood this, because he developed his understanding from looking at actual capitalism. So if you take any two prices, this should say equation 9.5. It doesn't, all the equation numbers disappeared. Damn it. I filled them in by hand, and I don't know what happened. Anyway, it doesn't matter for us. We can take that relationship from the previous one, and I can write any two prices as a ratio of their vertically integrated unit labor costs and a term which is simply the ratio of 1 plus the profit wage ratios of the two. This is just straightforward algebra from the first part. Everybody with me here? But now something very nice emerges. The unit labor costs are the wages times integrated labor times, and this term is a distribution term. And that basically says that I've broken any relative price into two terms, one which is a cost term and the other is a distribution term, the product of the two. It also follows from this that the rate of change of prices can be expressed as the rate of change of the cost term and the rate of change of the distribution term. Now this surprisingly simple analytical decomposition of an identity produces three hypotheses right away, which you recognize from Ricardo. First one is that this relationship here is made up of a structural component, which is wages and labor times. And indeed, if wages are roughly equalized, then it's only labor time. So that's the structure of production. And a distributional component, which is the profit-wage ratio in the sector. So one question would be, how much of an impact do changes in the distribution have on relative prices? If you remember reading Ricardo, this is one of the questions that he addresses in the famous 7% theory of price. And what he argues is that changes in this ratio are not going to have a big impact on relative prices. He says, consider the following. Suppose wages go up. Then profit to wage ratios will go down in every sector. And the ratio of the two will depend on the differences in other factors, like capital intensity. But obviously, this ratio, this number will go down and this number will go down. So the ratio of 1 plus that number will not change very much. And he gives a numerical example of a big change in wages, a big drop in profits. And he says, look, relative prices don't change very much. In fact, in his example, the effect of this part of a big change is only 7%. So relative prices are 93% the same. And that's the famous 93% of price. But you can see from the logic of this immediately that the argument is that the structural element is dominant. If the wages cancel out, this is just vertically integrated labor time ratio, which is labor value ratio in Marx. And that is the structural component, and the distributional component, according to Ricardo's hypothesis, is small. And you can see the logic for it. It's very important to understand that logic. It's important in this, by the way, to understand that this number here, sigma PW, is a vertically integrated profit-wage ratio. And this one is the vertically integrated of the jth sector, so that we're not looking at the profit-wage ratios. We're looking at the profit-wage ratio weighed plus the profit-wage ratio of the materials plus the profit-wage ratio of the materials, each one weighted by the relative share of the materials in the way back, so that we have a profit-wage ratio which reflects all the input path of the industry. So suppose I take this industry and I say the profit-wage ratio is some number, let's say 0.6. If I do the vertical integration, the profit-wage ratio might not be changed, but if I compare it to another industry and I do its vertical integration, they'll get closer together, because each vertically integrated profit-wage ratio is a convex combination of the profit-wage ratios of all the industries that enter into a given industry. So let's say each one of you has a profit-wage ratio. So I take the first one, and the vertically integrated profit-wage ratio will be a weighted average of all of yours according to how often you enter into this sector. But I take the second, your direct profit-wage ratio is one thing. Your vertically integrated one will be a weighted average of everybody's. And in a basic system where all the sectors are connected, it'd be a weighted average of everybody. So you can immediately see the implication of that. Vertically integrated wage profit ratios will be basically weighted average of the same set of numbers with different weights. These are called convex combinations, and that means that their dispersion will be much less than the direct ratios. And that's a point I'm going to come back to in a minute. So I want to explore the properties of this right away. So consider the following. I made two statements. One is that profit-wage ratios which are of concern are the vertically integrated ones. And that means that if I look at this ratio here, the size of this ratio depends on the extent to which these numbers are different from each other. And also, if they're smaller than 1, then that also damps the ratio. So the two things to consider. First, let's consider the size of these ratios. Suppose I had for industry I, one ratio is 4:0, and for industry J, the other ratio is 0.20. In other words, you had a 100% difference in these two industries, right? Then 1 plus, which is this disturbance term, so to speak, will be 1.4 over 1.2, and that will be 1.167. In other words, a 100% difference in the size of these ratios would result in only about a 16% deviation of relative prices from vertically integrated unit labor time, unit labor costs, and if the wages are equalized between that and unit labor time. This is a very powerful damping thing, and that's part of the example in Ricardo. So this is a cross-sectional, this is a structural hypothesis that says variations in these ratios will not have much of an impact on the relative prices, provided the rest of it are not changed. Okay? Now, a second hypothesis is that the rate of change of relative prices will depend on the sum of these rates of change over time. That's a temporal hypothesis. And so you can get three things from here. The first one is a structural, that changes in the distribution don't have much of an impact on relative prices. The second is the scale one, this one of 1.167. The relative prices will be roughly equal to unit labor cost because the second ratio will be not far from 1, 10%, 15%, and so on. And the third is that changes in relative prices will be roughly equal to changes in vertically integrated unit labor costs. So there are three hypotheses: structural hypothesis, cross-sectional hypothesis, and time series hypothesis. Ricardo says, first one gives me that structural element is dominant. It's about 93%. He says, for that reason, I'm going to assume that prices are roughly proportional to labor times. Natural prices are roughly proportional to labor time because the wage rate's the same and they cancel out in the case of competitive prices. And therefore, that implies that this deviation is also small in size, just smaller, in fact, than this in his estimation. But let's say it's a small number, 10, 5%, whatever. And then over time, the structural changes, the distributional elements don't change very much. And so you get a relation, a hypothesis that the rate of change of relative prices is related, strongly related to unit labor cost changes. And again, if you're talking about natural prices, the wage drops out. So you're really talking about a kind of labor theory of price, which is that in every case, the labor component, the integrated labor component, is dominant. Okay? Now, these three hypotheses lead to a series of empirical questions, and that's what I want to show you today. You can address these empirically. What you need is input-output tables and capital stock tables if you can construct them. So let's start with the first hypothesis, which is it true that relative prices are dominated by the structure because even when there's a big change in distribution, it doesn't have a big change on relative prices? And now an interesting question arises. How can you judge or look at a circumstance in which the distribution changes a lot, but the structure of production doesn't? One is you could use input-output tables. You could calculate this. But Jacob Schwartz, who was the premier professor at the Courant Institute of Mathematics, a famous computer scientist and mathematician, wrote a book about economics, and he did a simple test of the Ricardian hypothesis, which is stunningly simple and brilliant and obvious after it's been done by someone else. Oh, sorry, I skipped something. Let me go back a bit. I said here that for the structural hypothesis, we need to know what the size of this number is, and we also need to know the variation among the profit-wage ratios. Obviously, if they are very similar, then the number will be close to 1, whatever it is. If they're very different, it'll be further away from 1. I showed you 100% difference, and you only get a ratio of about 16% in the price labor time difference. So if you look in the United States, if you look across countries rather, European Union, the ratio of profits to wages is 0.282, direct profit to wages. United States is 0.31, Japan 0.25, and Canada 0.31. So they're in the order of 25 to 30%, the average. That means that this average number here for sigma is around 30%, plus or minus something. So this is a realistic statement of the expected variation. Then the other thing you can do is you can take in the input-output tables the column of profit-wage ratios. You can calculate from input-output table. And you can then calculate from that the vertically integrated profit-wage ratios, which is just the profit-wage ratio column times I minus A inverse in the matrix. And you can see what happens to the dispersion. And the dispersion will tell you what happens to the deviation of prices from labor times. You can, if you look at the direct profit-wage ratios, the mean is 0.46. The standard deviation is 0.74, and the coefficient of variation is 1.6. If you take the integrated ratios, direct and indirect, then the mean is not changed because you're taking a weighted average of the same set of numbers with weights adding up to 1. So the mean is not changed, but look what happens to the standard deviation. it drops from 0.74 to 0.27. So the coefficient of variation drops from 1.6 to 0.55, roughly a 30% drop in the coefficient of variation. Does everybody intuitively understand that? It's a very important point, and I think people didn't see this before, but it's quite important to understand that what happens is if I take a set of numbers, each one of you has a profit-wage ratio, and I replace that with a combination, a convex combination of that set of numbers with different weights, all positive weights in a basic system, then each one of you will get a new profit-wage ratio, but that'll be a weighted average of all the others. You can see why everybody's is a weighted average of all the original numbers, so they're going to be much closer together in terms of their distribution than they were before. Is that clear? And that implies that the deviations of relative prices from relative labor times, in the case of prices of production, or relative unit labor costs, is going to be much smaller than you think, because it depends not on profit-wage ratios, but on these vertically integrated ones. And they get, basically you have a distribution of profit-wage ratios, and when you do the vertical integration, you get the same mean, but the distribution is much narrower. So the coefficient of variation is much smaller, which means, therefore, that this average deviation would be smaller. Okay? So now we come to Schwarz's test. And Schwarz says, under what conditions could I examine an economy in which the structure of production doesn't change, but distribution changes a lot? This is Ricardo's numerical example, by the way. Exactly, the structure of production doesn't change, but distribution changes a lot. And Schwarz comes up with this brilliant notion. What if I look at prices and distribution at the top of a business cycle and the bottom? The business cycle is pretty short. It's less than a year, maybe a year and a half. So in that time, not much happens to the technology. But a lot happens to profits and wages, because you go from the top to the bottom, profits plummet, so the profit-wage ratio drops sharply, and yet not much in the structure of production. So what he's going to do is he's going to take a bunch of business cycles, including the Great Depression. So he's taking a big disturbance, and he's going to look at relative prices at the top and the bottom on average, and he's going to see how much do they vary. And this way he can assess empirically the sensitivity of relative prices to a big change in distribution. These are market prices now. So they include disequilibrium and monopoly and everything. And what he finds is if you look from the top to the bottom of business cycles of 4 business cycles from 1919 to 1938, you find the variation in output is 33%, auto production is 60%, cotton is 30%, housing contracts is 40%, and the factory pay, variation in wages, is 40%. So these are big variations over a business cycle. However, when you look in relative prices, then you find for semi-manufacturing goods, 7%, raw materials, 9%, wholesale foods, 2%, retail foods, 4%, pig iron, 12%, farm prices, 10%, and average variation of 7%, which is Ricardo's exact number. Now, Ricardo was not a psychic. He came to this number from observation, and this is how, in fact, Schwarz comes to it too. As a mathematician, he sets up an experiment where he can see the 2 components, holding one constant, varying the other, and he gets a variation of 7%. This is such a simple, clear, brilliant thing, and nobody thought of it until Schwarz thought of it, as far as I know. Okay? So here's a test of Ricardo's, and you can see, by the way, why Ricardo could have observed this. He could have observed prices changing over cycles, and he could have seen that they don't change very much. So he could have constructed this numerical example to illustrate the observation, illustrate the numerical result, the scientific result. This is an experiment, a wonderful experiment. So now if you, a student who used to be in this course before by the name of Claudio Putti from Brazil, who is now a senator in Brazil, did his dissertation on extending the Schwartz test over modern business cycles, because Schwartz did this in the 1950s and early 60s, and now we have all this data on downloadable and all of that. So what he did is he looked at business cycles over 31 business cycles, and he determined the cycle in two different ways. One is by the NBR criterion, and the other by looking at individual industries, see their peak and trough. We wanted to see if that would make a difference. And basically the result is that if you look at quantities, you see that prices vary by about 8%, and quantities vary by about 30%. And if you look local cycles, prices vary by 9%, and these quantities vary a little bit more, closer to 35%. In other words, the results are very much like Schwartz. You get huge variation in quantities and wages, but very little variation in relative price. And the reason is because if wages go up, profits go down. So that, or if profits go down in a trough, then the profit-wage ratio goes down for every sector. So the relative effect is not so great. So that's the first test. It's a structural test. And you can see that you get a very good, strong result. We're looking here at market prices and direct prices. Direct prices are prices proportional to labor time. So the first question you want to ask for Ricardo's second hypothesis is how far are market prices from direct prices? And market prices include monopoly and disequilibrium, so that distance should be the biggest. The logical argument in the classical tradition is direct prices, which is a structural element, to market prices, to prices of production, which are the competitive element, to market prices. So that's a chain of reasoning. You start with prices proportional to labor time because that's the main structural element. You ask how far are competitive prices from that? And since competitive prices regulate market prices, that's the third step. Okay? So we're looking now at, we're jumping the two and we're going straight from the biggest distance should be from here to turbulent market prices. That's the upper bound, so to speak, in the story. And if you look at a picture of, this is calculated from US input-output tables. You have prices proportional to labor time, which is the direct prices, and here are the observed market prices. This line is a 45-degree line because they're normalized to have the same average so that you can see whether they're close to each other. It's not a regression. And you can see how astonishingly close these are to each other. And now you can do this calculation. It's straightforward in an input-output table. All you need is labor coefficients and the A matrix, and you can make this calculation. If you then look at the degree of difference, another translation problem. I realize now, well, I have to start making PDFs because the Macintosh doesn't read the PowerPoint or even the word symbols so that you lose them. So I'll try and do that next time as a PDF. These are different measures of deviations. This is the mean average weighted deviation. So you take the average deviation and you weight it by each sector's weight in the share in the total, and that's one measure. This is a measure similar to that, except it's scale-free. This is coefficient of variation, which is another matter of distance, and this is the Euclidean norm, Euclidean distance. All of these are distance measures between two vectors. You have a vector here of market prices and a vector of direct prices, prices proportional to labor time. We want to know how far apart are they. And the different measures give you roughly the same result, which is that, I should have printed this out. You can't see it, but I can. The average deviation over the different years for, I'm just going to focus on one, which is this middle measure, which is very close to what Marx and Ricardo use as measures of deviation, is 15%. So the deviations vary between 15 and 18%. And this is the biggest set, the most greatest distances would be expected between prices proportional to labor time and market prices. Okay, so we're talking on the order of 15 to 18% for such a deviation. Another question which I can ask is the third part of Ricardo's hypothesis, which is how do changes in market prices, how are they related to changes in some other set of prices? So for instance, if we go back to Ricardo's third hypothesis here, time series hypothesis, the rate of change of prices is a function of the rate of change is roughly equal to the rate of change of unit labor costs in Ricardo's hypothesis because the rest of that is small. So we can ask that. We can ask, what does the evidence indicate? Is the relationship between direct prices here and market prices here compared between 2 years, 67 and 72. So this is the change in market prices in this 5-year interval, and this is the corresponding change in direct prices in that interval. So we're looking to see what extent do market price changes reflect changes in direct and indirect labor time, basically, or direct and indirect unit labor costs. Now here the difference is 5 years. This is 72 versus 63, so this is a longer distance of 9 years. This is an even longer distance and an even longer distance. And what's striking is that even a distance differences as much as 9 years or more, up to, this is what, 14, 58, 68, 10, 72, 14 years, you can still see a strong relationship between relative prices and structure of production. And that is a way of assessing Ricardo's hypothesis that the structure of production dominates the changes in relative prices. Here is market price and direct price. If I take the interval of 4 to 5 years, you can see that the R-squares are very high, and you can do that because these are each normalized so that they don't have a quantity component in them. They're ratios. So you get variations of between 3 and 4% in the distance between the two. So that says that really these are very close to each other. The distances are on the order of 3%. So the change in market price compared to the change in productivity, basically, the two are virtually the same, up to about 96%. If I take a longer interval, you see the distance is greater, but it's between 4 and 6%. So it still means that 94 to 96% of the changes in market prices are explained by productivity, even over a 9-year interval, which is a remarkably strong result. And that ratio doesn't change a whole lot as you go over time. Different numbers give you different ratios, but basically you see this is the length of a decennial business cycle, so fixed capital cycle, and you see these numbers vary from about 4% to 8% depending on the measure used. Okay? So that already establishes something very strong, which is that there is a strong relationship between market prices and productivity change, structural change. Now I want to move to the intermediate part of the story, which is the relationship between direct prices and prices of production, because that's the theoretical one. That's the core of the price value deviation issue in Marx, the transformation problem, all the debates about Sraffa prices versus their variation from their starting point. All of those issues are located there. Everybody understand that issue? So that's a core theoretical debate. The first one was an empirical one about market prices, but here we're talking about two sets of theoretical prices, prices proportional to labor time and prices that reflect equal rates of profit. How different are they? The whole debate on the transformation problem for the 100 and some years is on this issue alone. But people didn't ask how big the difference is. They focused only on the fact that they are different. Here is, to calculate prices of production, you need to know fixed capital. And there are two ways, traditionally in the literature. One is the cheating way, which is to assume that there is no fixed capital. So you assume that circulating capital, which is materials, is the same as fixed capital. And that's done principally because you don't have data. But I actually calculated data on fixed capital. So, and you can see it doesn't make a huge difference, but it does. Here is direct prices, and here are prices of production. Again, they're scaled, so they are averaged the same, so that the 45-degree line is a visual point determining their distances. And you can see how closely they stand in relation to each other. Now, when you calculate fixed capital, then this same one here, 1998, becomes this, and 1972 becomes this. You can see it's incredibly tight, these relationships. And that says that the deviation of direct and indirect labor time from prices of production, which is the whole issue in the theoretical literature, is on the order of 13 to 18% on average. Again, the same order as the market price, direct price one. So the first one, this one is on the order of 13 to 18%, and then this one is on the order of 13 to 18%. So the normal deviation is, let's say, 15%. That's in the center of that. And that means that 85% of the variations in market prices can be explained directly from variations in direct and indirect labor, unit labor costs. And 85% of the variations in prices of production can also be explained that way. So now we want to move to the time series relation between, again, direct price and price of production. And you can see that here we are looking at, so here I'm trying to look at time series, and I'm taking them in 1 year and comparing them in another year. In other words, here is 1972 compared to 1967. Since I can calculate direct price to price of production ratios in each year, I'm basically asking to what extent does the ratio of the two change over time, how's ratio in 1 year explain the ratio in another year. And you can see that you get in the interval from 5 years, they're very tight. This is an interval from 63 to 72, so that's a longer interval of 9 years. It's still very tight. In fact, it's tighter. Then you get the interval longer than that, you see the relationship gets weaker. So up to 5 or 9 years, you can explain the movements of one by the movements of the other. This is another way of looking at that test. Any questions about this? And this is just again, the empirical version of what I just did. If you compare them in 2 years, you see these ratios can be compared. Over a 4 or 5 year interval, they have R squares on the order of 0.9697, which is a very, very strong relation. And over 9 years, they have closer to 0.9. 11, they get slower. 14 actually gets bigger. It's not very clear why, but then you can see that they get lower. I suspect because 1958 was a particularly different year, a special year. And you can see the size of the deviation, 2 to 3%, 4 to 5 years, 2 to 5% for 9 years, and so on. So really, the structural relation between production prices and direct prices is enormously strong. To put it another way, the whole transformation problem is really about these small numbers, 3%, 5% in the biggest case 15%. Now we come to the third possible combination, which is this one, which is price of production and market price. Because we have a chain here, direct price to market price, direct price to price of production, and now price of production to market price. We're basically decomposing the elements, the steps in there. And again here, either cross-sectionally, using circulating capital only or having fixed capital, you can see very clearly that the relationships are extremely strong. Most empirical hypotheses had a curve, a scatter like this. You would say, well, that's it. It's absolutely solid. And this is in every year repeated. I'm only showing you a couple of years. And this is the, again, empirical measure of the deviation in the two sets of vectors. And you can see that the average is between 15 and 20%. These are all scale-free, except for the first one. These are scale-free measures, so they're not affected by units or anything like that. And these are at observed market prices, observed output flows and input-output relations in different years. Okay, so let me just stop here for a moment and reiterate, go back to what I started with, which is that if you start with Adam Smith's decomposition, you can break any price into two components, which is the vertically integrated unit labor cost and the profit-wage ratio. And that means that any relative price can be broken into a structural component and a distribution component. And if we have prices of production, the wages cancel out, so the structural component is really direct and indirect labor times ratios, labor value ratios, and the distributional one is a profit-wage ratio. And we saw that from there you can derive three hypotheses. You can ask to what extent are relative prices sensitive to changes in distribution holding structure or production constant. And that's the Schwartz test and the Putty extension of it, and that says that on average, 7% variation in relative prices due to huge changes in distribution. And that's exactly the number that Ricardo illustrates. And I said it's not because he's a psychic, but because he has the sense to have observed these things in actual practice. So these numbers he's illustrating are numbers that he's observed by watching how people, what happens in business cycles. Then the second hypothesis you can generate from this simple relationship is that this part is big relative to this, because this is 1 plus a number less than 1, and this is 1 plus a number less than 1. And if those two numbers were 0.4 and 0.2, this whole ratio would be a disturbance term of about 16%. And that happens to be the size that we generally find. So you can say that you could expect from that, Ricardo's second hypothesis, that this relationship between relative prices and relative unit labor costs holds to the order of about 85%. And it does. The deviations are on the order of 13 to 15%, 17%. And then the third one is a time series, which is the rate of change of these relative to the rate of change of the structural component. And again, you see that this structural component dominates the actual market prices, and it dominates theoretical competitive prices. So it is, at a first approximation, extremely accurate to say that the structure prices can be broken into two terms, of which one is by far the dominant one, and that's the structure of direct and indirect unit labor costs. Okay? Now think of the theoretical strength of this when you're doing analysis, economic analysis. We saw that I can, in effect, predict relative prices over a 5-year period and even a 9-year period by knowing what's happening to the structure of production. to an accuracy of 96, 95, 96, 97%. And that's a very, very powerful proposition. It means that you can do analysis of prices of industries. These are 75 order industries. So you're talking of detail here, input-output detail. And yet I can still predict to a great degree of accuracy the movements of relative prices, knowing only one thing, which is the structure of production. If I know more, such as a distribution and capital output ratios and all that, I can get a different measure, but it's actually not much more accurate because all the turbulence in market prices and other elements seem to give you roughly the same distance regardless. So that you can see why the classical economists, especially Ricardo, would say, look, I know all that, so I'm going to make the assumption that the difference between these two elements is small in the long run, or at least that the second one dominates the first, and so I can simplify my analysis greatly by ignoring the second, by treating it as an error term. And it is kind of an error term. It's distributed in such a way as you can think of it as a random error. And so you can say that you can have a model of relative prices, which is Ricardo's model. Relative prices equal to relative labor times, direct and indirect, plus an error term. And the error term gives you on the order of 10 to 15 or 20% at most, between 13 and 20%. And when you look at time series, you get the error term is on the order of 3%. And Ricardo explains many things empirically this way. You can also see why Marx would understand that this was a difference between structure and distribution. Any questions here? Notice how different this is as an understanding of relative price from the neoclassical notion of price being a liquid scarcity reflecting variable. The classical economists insist that market prices reflect demand and supply. And indeed, those goods which cannot be increased, then they reflect the scarcity of the good relative to demand. But that doesn't mean that market prices are regulated by demand and supply, because supply changes. If the price of market price is above the price of production, and that brings the price down towards the price of production in a turbulent manner. And so the structural determination of relative prices ends up as being the dominant element. Now you can imagine writing, working on macro models, let's say, a concrete macro model. It becomes very important in macro modeling to know how to model the different sectoral prices. A link between sectoral prices and productivity is an enormously powerful tool for understanding the effects of, on relative prices of technical change. And you can also do it for distribution. All the elements are here, but the distribution element is clearly smaller. So at first approximation, you can say relative prices are driven by relative degrees of technical change. Or in Marx's sense, relative prices are determined by direct and indirect labor time, or relative prices are driven by relative labor values. And let me read you this quote from Marx. He's making this point that this is the dominant element. Changes in relative prices are determined by changes in relative unit labor costs, but these are equal to changes in labor values because the wages are the same in a competitive price, in the price of production. And so he says, I quote, this is from volume 1 of Capital, no matter how prices are regulated, the law of value dominates price movements with reductions or increases in the required labor time, making prices of production fall or rise. It is in this sense that Ricardo, who doubtlessly realized that his prices of production deviated from the values of commodities, says that the inquiry says, I quote, he's quoting from Ricardo, the inquiry to which I wish to draw the reader's attention relates to the effect of the variations in the relative values of commodities and not in their absolute value. In other words, variation in their relative prices and not their absolute level. This brings us back to the classical issue, which is the relationship between prices of production and what I'm calling integrated labor time. Marx calls labor values. We began by establishing that for any prices, I can write this is just an identity. Okay? This number, sigma PW, is just the ratio of vertically integrated profits over vertically integrated wages. T means total. So if I think of this as the vertically integrated wage profits, direct and indirect, and vertically integrated wages, direct and indirect. So or I can write this as a profit rate times the vertically integrated capital stock over the wage rate times the vertically integrated labor. They don't have to be equal in the two different sectors, but this is just an identity. I've just broken it into components. I can always define, if I define the direct and indirect capital stock, then divided by the direct and divided into the direct and indirect profit, I get a profit rate. Same thing for the wage. So I can write this as all I've done is express the components in a different way. So what is this saying? Any relative price is a ratio of the wages, direct and indirect, the average integrated wages, the integrated labor time ratio, and the integrated profit wage ratios, which is broken down itself into a profit rate to wage rate ratio and a capital to labor ratio integrated. Integrating means direct and indirect. And you understand that just means you replace the observed ratio by the direct and indirect one for any particular industry. It's a straightforward calculation. So this is for any price. But for prices of production, we have the wages are equalized. By definition, a price of production is reflecting equal wages and equal profit rates. So that means that for prices of production, which I'm going to use a star for, that's going to be, the wages are going to cancel out. So you're going to get W over W, so that cancels out. You get VI over VJ. I'm going to leave out the W because you can see that they cancel out. And that's your labor value ratio in the sense of Marx, times 1 plus R over W KL I, KLTI, and 1 plus R over W KLTJ. And that's a very nice result. Because that says that relative prices deviate from relative labor values only according to the size of these relative terms. And their deviation from each other depends only to the extent to which their vertically integrated capital labor ratios differ from each other. Notice I said vertically integrated because the direct capital labor ratios may differ a lot more than the vertically integrated one. Vertical integration squishes the distribution, and therefore it's going to squish the distribution of this. Okay? And in effect, we can also see that if vertically integrated capital labor ratios are equal or close to each other, then prices will be very close to labor times. And when you put it this way, I haven't done anything other than high school algebra here so far. And in my opinion, this was already intuitively and maybe even practically obvious to Smith and Ricardo and Marx. Now, I could do this with linear algebra to impress you, but it's on my homepage. You can do that yourself. You get the same notion. But so far, this is just straightforward, simple, analytical decomposition of the price of any commodity. And that's led me to this result. And we see empirically, we can estimate these numbers, all of these numbers. And we see that this component seems to add 10, 15% in a static cross-sectional variation. And if you then look at, from here, the rate of change of relative prices of production, by definition, it'll be the rate of change of their integrated labor times plus the rate of change of this term. And if you think about this term as a disturbance term, then you can get the sense of the classical idea that prices are dominated by these labor times plus a disturbance term. And we've seen that this disturbance term for changes can be quite small, in fact. We saw that, the order of 3-5% for 5-year periods. That's a big thing. We're talking about structural change here. 4 or 5-year period, and maybe a little bit higher for a 9-year period. And that tells us also that the key thing is that the changes in capital labor ratio are themselves structural. They are the structure of production of the columns of a matrix. And if that changes slowly, and moreover, the integrated columns are similar, they will be more similar than the direct columns, you would expect to see this number not to be very big. Let me just explain that a little bit. An input-output matrix is a matrix with coefficients aij. I'm going to define a matrix, and let's say we have a capital stock matrix, a capital stock vector, which is going to be elements k1, k2, kn. So this is a vector where this aij is a11, a12, a21, a22 in a 2x2, and this one will be k1, k2 in a 2x2. What's of interest to us is not the differences in these columns, but the differences in a matrix H, K, I minus A inverse. I didn't do this right already. Damn. It should be capital coefficients, not a vector. And this I minus A inverse matrix can be written as K I plus A squared, so on. And that tells us that this H, which is the vertically integrated capital coefficients matrix, K is a direct one, H is a vertically integrated one, is equal to the direct one plus the inputs, the capital inputs of the direct one plus the capital inputs of the capital inputs of the direct one, and so on. So you can think of this as a process that creates a new matrix, and the new matrix will have columns that are more similar to each other because they're basically multiplied by this I minus A inverse. They are transformed by this product here. And you can do this. You can do this in a simple numerical example. Make up these numbers, keeping your A matrix to be an input-output matrix, semi-positive and indecomposable if you're looking at basic goods, and you'll see that the columns will become more similar. Yes?
Like, one point of clarification is that you can, like, I was wondering if the reason that you can translate that I minus A, the minus 1 to that convergent series is because the coefficients are between 0 and 1, right?
No, it doesn't have to be. It depends. If you measure these in price terms, yes. So typically, real input-output tables have a price here, and a price here, and a price here, and a price here. So this is the price of the first good used in the first industry, price of the second good used in the first industry. Now, these numbers have to add up to be less than 1 because this is a cost. And this has to be divided by the price of the first industry. And this is divided by the price of the second industry. So these numbers have to add up to be less than 1 because this is the cost relative to price. It has to be less than 1. However, if you're looking at physical coefficients, that's not necessarily the case. But these two matrices, this one with prices and this one without prices, are similarity transforms. That means that the eigenvalues are exactly the same, and it doesn't matter whether we use the column sums adding up to one criterion or not. Input-output tables in the theoretical sense have this property that their I minus A inverse can be expressed as a convergent series by first taking it into this form if you want, and then saying the column sums are less than 1.
What does the K11 stand for?
It's this is the raw materials. Yeah, I know. This is the raw materials used in the first type in the first industries. Raw materials, the second type. This is the capital equipment used. So this is machinery and plant here, which is different from raw materials. Now, strictly speaking, if machinery and plant were different items, which they are in input-output tables, then there'd be 2 more rows here, which are 0 because they're not raw materials. And here there'd be 2 more rows which are 0 elsewhere up here, which are because the raw materials are not capital goods. And the number of zeros plays a role in the mathematics of all of this, which I get into in the book, but I don't have time here for. Okay. Any questions about this? So this is leading us in a particular direction. And that direction is that if you approach relative prices from this point of view, you actually have a very powerful, empirically powerful, analytically powerful, simple story of the determinants of relative prices and of their relative significance. Now, it's interesting that Ricardo goes from here to the hypothesis that this is a kind of disturbance term. And let me explain that for a moment, the idea of a disturbance term, because this also follows naturally from these equations. Sorry about that, but my PowerPoint is kaput. so I can't do anything about that. But if I look at prices of production here, now let's say I call this VI over VJ times some disturbance term, right? Some product term. Now, I can write this as the log of PI star over PJ star. And this is, again, an equality, exact equality, is equal to the log of VI over VJ plus the log of this disturbance term. And so that means that we've broken the identity into a log linear relationship, right? And if this term can be viewed as a sort of random variable of some sort, not necessarily symmetric and all that, but the mean, we're basically saying that there's a relationship between the log of relative prices and the log of integrated labor times, log of labor values, and a disturbance term, and we're seeing again that the disturbance term is small. You can look at this disturbance term empirically. You can look at its distribution. You can look at its mean. You can look at its log properties and all of that. And you can show, in effect, you can understand how the classical economists saw the world of relative prices. This brings out also the great importance of technical change. Because here's technical change right here. And this is what the quote from Marx is about, says that it depends on what's happening to the relative labor values. A sector which has high technical change relative to others will have its labor value fall relative to others. And that'll drag down its price. Now, if I said to you, look, everybody knows, every businessman knows, every business person knows that prices are driven by cost cutting, and cost cutting is driven primarily by improving technology and raising the productivity of labor. You don't have to go to Harvard Law School to figure that out. But that's essentially what this is saying. It's exactly the same. Business people observe it at the micro level. This is making it into an analytical statement that you can aggregate up to any level you want. Okay? These are relative prices. This is not about the price level, because that can go up and down with inflation. The question is what's happening to the relative prices. Okay. Any questions here? So Ricardo, Smith, and Marx are quite right to say that both cross-sectionally and over time, relative prices are dominated by the structure of production, and that the distributional elements have an effect, but the effect is relatively small. And in many circumstances, that effect can be treated as a secondary factor, and you can work on the primary one to see the properties of that. Notice that this is not a statement about equilibrium, because even the discussion of direct prices to market prices, which is all disequilibrium, monopoly, tariffs, foreign trade, everything stuck in here, is still talking about order of magnitude of 13 to 18% for cross-sectional, and time series a much smaller variation. So I can say in practical terms, I can even skip the intermediate steps and get a good practical estimate, but the intermediate steps are important for analytical reasons. And now an interesting question arises. You will notice that in the data that I showed, all of these deviations tend to be on the same order of magnitude. And that doesn't make sense. Because if you believe that market prices are regulated by prices of production, so market prices fluctuate around price of production, and prices of production are regulated by relative labor values, which may be a higher or bigger number, then you're talking about a picture that looks like this. Let's suppose that we had market prices Pi, Pj. And market prices are, in fact, according to this, regulated by prices of production. So everybody understand this is time here? And this is relative price. And the hypothesis in the classical argument is that the market price fluctuates around this invisible, non-existent center of gravity, because it's created by, if you go higher, supply expands and you come down. There's no such thing at any moment of time market price. It's a center of gravity due to the equalization of profit rates. And we know, according to the classical hypothesis, that the relative price is not the same thing as the relative labor value. It can be above or below. So I'm going to draw it below just for the sake of it. But let's say that here, Vi over Vj. So this one is driving price of production, and price of production is driving market prices. So it seems sort of intuitively that market prices would be closer to prices of production than they would be to labor values, right? And this, the fact that the numbers are not very different has led some people like Farjoun and Markover, for instance, and Flaschel, to say, well, in fact, we don't need the intermediate step. We can just jump here because, in fact, there isn't any intermediate step since it doesn't, you don't gain anything in the size because the average deviations tend to be the same observed. But this, I think, is a mistake because it mixes vector norms with scalar differences. Vector norms are not additive. Here it seems plausible that the deviation of market price from price of production is smaller than the deviation of market price from labor value. But what we're looking at is not the sort of sum of these deviations. We're looking at the vector distance. And vector distances, it doesn't follow that if you decompose these distances, they will add up so that they rank, so to speak, that one is the sum of the others, because that doesn't work with vector norms. So it's possible to explain, and in the book I do this. I show exactly an example, a three-sector example, in which I have prices of production moving in some way. I have labor values different from prices of production. They can be calculated in a three-sector example. And I have market prices fluctuating randomly around price of production. And I ask, will these numbers be such that they be different? And you can see that they're not. It's because these are, the norms don't add up, so to speak. The sum of, the norm of a difference is not the difference of the norms. Or the norm of a sum is not the sum of the norms. Okay? So that explains another puzzle in the literature, which is that on the classical hypothesis, this is correct, but it doesn't follow from these measures, distance measures, that the distances will be bigger or smaller according to whether we look at the first two or the first and the third, or even the second and the third. Okay, so let me summarize what I've said so far, because next week or on Friday I want to get into the harder stuff, which is the analytics of the price production and Srafa and all of that. I've said that the classical theory of relative price begins by saying that market prices respond to demand and supply. So market prices are very responsive. However, in the long run, market prices break into two parts: those which reflect demand only because the supply cannot be expanded, rare goods, wines, and so on. And those which reflect cost because the supply can be expanded, and then the cost of production becomes the crucial variable. And the classical way of splitting it up into two parts, which can be done from an identity, is to think of it as unit labor costs as the dominant component, and the distributional component, which depends on profit rate equalization, capital labor ratios, and all of those other things. And these are, in the classical argument, second order for industries in general, though individual industries, it might be big. One of the reasons Marx gives for not accepting Ricardo's proposition that market prices or prices of production are roughly equal to labor values, labor times in Ricardo, is he says for individual commodities these can be very different. And the whole point of the transformation problem in Marx is to show that they are very different. Nonetheless, over time, changes in prices of production will be dominated by changes in labor values because these components change slowly. And we can observe that. We saw that the empirical evidence strongly supports all of these propositions, the three Ricardian propositions. The one is that the structural change is dominant, that the distribution has a second order effect on relative prices, holding other things constant. The second is that the variations in capital labor ratio, so to speak, don't create much of a cross-sectional variation, independent of the structural one. And the third is that over time, variations in relative prices are dominated also by the structure. This then raises a question, which is that in the theoretical literature, prices of production themselves are viewed as being very variable. This is Sraffa. And I'm going to try to introduce you to Sraffa's argument here, but intuitively think of it the following way. Suppose I change the profit rate ratio. I change the the wage rate. Then the profit rate will go down. The wage rate goes up, profit wage goes down. So in both sectors, in all sectors, this ratio of R over W will move in the same way. What effect it has on the overall price depends on how their capital labor ratios are different. But Sraffa's point is that the capital here is itself measured in money. So it's not independent of the prices. So if I change the distribution and prices change, then the capital labor ratio can change. So an industry which had a higher capital labor ratio could in principle move to becoming a lower one and vice versa. So sort of biblical exchange of capital labor ratios. The high should be made low and the low should be made high. Sraffa's argument is that this is an intrinsic property or imminent possibility at least in the theoretical calculation of price of production, and therefore we cannot say anything about the direction of these deviations from the capital labor ratios because they themselves can change as prices change. And we can test that, again, empirically. We can test to see whether that direction does change. And implicitly it doesn't because we have tested the relationship here relative to these over time, and we see that if this were to change a lot, that relationship wouldn't hold. So we've implicitly shown it doesn't. We need to show analytically why Sraffa's argument, which is in principle correct, is not correct in practice, and that raises the question, why not? And the answer is because prices do not seem to move in the complicated way that Sraffa says is possible when we look at them empirically. And we then are forced to ask, what is it about the actual structure of input-output tables and the structure of relative prices that is missing from the analytical argument? Remember the key point here. If you're going to approach this from a scientific point of view, your job is to understand how it actually works. And if a proposition that you have is not obtained after repeated samples, repeated experiments, then you need to ask why not. Why not meaning what am I doing wrong, not what the world is doing wrong. So for instance, if I take a coin and I flip a coin, what are the probabilities? What are the outcomes and what are the probabilities? What will I get if I flip a coin? What are the outcomes? First of all, what are the outcomes? Heads and tails. And the probability of the coins are fair? 50-50, right? But that's actually not true. There's a third probability, third possibility, which is that the coin lands on its edge. The fatter the edge, the more probable that is, right? So we already, when you get concrete, and you move away from a hypothetical coin to a real coin, you can get the possibility of a coin landing on an edge. Any good magician can do this easily to make it land on its edge. So now you have 3 possibilities. And you need to know, even if it's not a trick, you need to know what is the probability of that third part. So when you look at the 3, it seems, well, there are 3 possibilities, but then you need more concrete information, like the surface area of the coin and the thinness of the edge and the surface of the ground to know the probabilities of its landing on the edge and staying there. If the ground is soft, like mud, you do it, you'll find it does. If the edge is thick and even the ground is relatively hard, it may stand and roll. So you have to be more concrete. And it's not adequate for you to say, well, in my model, each of these is equally probable. But when you toss them, they're not, and you need to find out why. And what we're finding from the empirical evidence is that certain results are very strong and others are not, and we need to ask why. And there is a modern debate, which I will try to present to you, which explains why that might be the case. Though I have to say it's not resolved yet. So I'm going to pick up the second part of this discussion next week, now on Friday. And then we're going to move on to whatever the next topic is, which if I remember is the theory of finance.